Hello, good afternoon, good morning, good evening, wherever you're tuning in from, and welcome back to my channel. And this is for the love of chemistry. Here we make chemistry simple and easy. Alright, so today we are going to be working on calculations in chemistry. Calculations arising from different gas laws. And for today, we are going to look at the Boyle's law, the Charles law, and the general gas equations. Okay, so we are going to deal with calculations coming from there. And if you are preparing for Jamb, for physics, for NECO, for WAEC, this is good for you. If you are also in SS1 and you are about to do this is good for you. And even if you are in SS2, you need a reminder because your assembly work and every other thing is a build-up of what you've done in your previous classes. Okay, so this is for everyone. All right, so quickly, we are here with a question already and we want to see how we can solve this question. And what I'm going to teach you is step by step how you can solve any question under gas law that comes under this. Okay, so let's quickly look at this example and see how this works. All right, the question says, a given quantity of gas occupies a volume of 228 cm cube at a pressure of 750 millimeter mercury. What will be its volume at atmospheric pressure? All right, excuse me. So first, our solution, the first step is always to list every parameter given. So the first parameter here is volume. So volume, we call it V1, is equals to 228 cm cube. And the next parameter given was the pressure. And V2, not V1, P1 pressure is equals to 750 millimeter mercury. All right. What will be its volume at atmospheric pressure? So we are looking for V2. And atmospheric pressure, P1, atmospheric pressure can be in atmosphere, it can be in millimeter mercury, it can be in Newton per meter square. But for the sake of this calculation, the first pressure that was given, the unit was millimeter mercury. So we will use the atmospheric pressure at millimeter mercury, and it is 760 millimeter mercury. This is our standard pressure under this particular unit. So now that we've listed all the parameters, this will give us an idea of the particular law that consists of this. So when we have pressure and volume, the law here is Boyle's law. And Boyle's law states that the volume of a given mass of a gas is inversely proportional to its pressure at constant temperature. So here we don't have temperature, we have just the volume and the pressure, which shows that temperature in this case is what? Is constant. It wasn't mentioned, so we assume that it is constant. So here we are asked to find V2. And from what we have done now, from the parameters, we know the particular law and we've stated the law. The next thing we are going to do is to write down the equation for that law. And it is P1 V1 equals to P2 V2. Now the next step is to make what we are looking for subject of the formula. So when we make V2 subject of the formula, let me go a bit elementary just for this particular teaching because I haven't done it before, but subsequently I'll just write the correct formula. So if you want to make V2 the subject of the formula, then you divide both sides by the coefficient of V2, which is what? P2. So if we divide both sides by the coefficient of V2, because we want only V2 to be on its own, so we divide both sides by P2. So P2 cancels P2. We have that our V2 is equals to P1 V1 all over P2. Is that clear? So that is making V2 subject of the formula. Now that we've made V2 subject of the formula, we can now fill in our parameters. We have that P1 is 750, V1 is 228 all over, P2 is 760. And when you calculate using your calculator, you will find out that this will give us 225 cm cube, and that is the answer for V2.